Good evening, everybody. It's a pleasure for me to be here to present and moderate the first international webinar of Erquadro. In the end of 2024, Erquadro opened a new branch in Denmark. So today we have an hybrid audience, both Danish and Italian participants. A great pleasure for us. We have a light change in the agenda since our speaker from Pirelli, Sergio Lasca, could not attend due to personal issues, and he will be substituted by our sales manager, who was the key account of Pirelli. So he's the best person to substitute Sergio for doing so. As you may know, at the end of the webinar, we give the opportunity to the audience to ask questions. So you can find question and answer button in Zoom, then you can write your curiosity, and I will collect them and ask questions to the speaker at the end of the speech. Okay, regarding the webinar of today, I would like to start from an important assumption. Modern products are complex systems and are made of mechanical, electronic, and software components, where the balance between these three parts shifts depending on new technologies. A deep understanding of how our product is made, how it is organized into subsystems, is essential to drive innovation of the product itself. So in this webinar, we will explore exactly this. We will explore the concept of system of systems, and also provide insight into innovation strategies and methods for thriving in competitive markets. I don't steal more time. I'm glad to present the first speaker of today, who is Niels Henrik Mortensen, that is professor and head of section of DTU Construct, that will present systematic product portfolio development as system approach. Niels, the floor is yours. Thank you very much.
And Sylvia, just to be sure, the time frame for this presentation, what is the time cap?
15 minutes.
15 minutes?
Yeah.
Okay.
Thank you.
Good. Good. Fantastic. Well, I'm very honored to be in this seminar. And I will give you an introduction to an area that we call modular design and manufacturing. And basically, you can say we are in all companies very much organized in development around one product, that we go and design this. Now we shall do a new washing machine, we shall do a new vacuum cleaner, or whatever we shall do. And there we organized in a financial model that we try to optimize that product. Let's have it with the best cost effectiveness we can have. Let's have it with the best manufacturing. And then we get a new idea for a new product, and when we get a new idea, and it means that the portfolio is expanding over time. And in many big companies, we become more and more complex over time. And now imagine we shall have a new feature. If this was an oven, we shall integrate a new feature in the oven. Then we would have to do a new development here, one new here, one new here. So we become slower and slower over time on upgrading the portfolio. And therefore, we need an approach to, let's say, design whole portfolios, and we call that modular design and modular manufacturing. So this is what this presentation will say something about. And very briefly, a little bit about the section where I belong. And then I'll try to say something about the lessons learned from 300 initiatives. We have been in 300 modernization projects around the world, a little bit on what we have learned there. So we basically study engineering design and how can we become better here, from the idea, from the conceptual to the detailed design, to testing, verification, and ramp up in manufacturing. And I know in Italy you are perfect, everything is good, but here in Denmark we are a little bit bad on all phases. We are not good on requirements, we are not good on conceptual design, we're not good on testing. So here we can, let's say, improve along the many areas that we have here. And if we take two different products, then we can say we can have a very integrated, this is a welding machine, we can have a very integrated way. And it will almost forever sit with poor quality. You never get the good manufacturing quality. You never know which wires to put on here. So it's difficult to improve. It's difficult to upgrade. It's difficult to improve over time. And this is fantastic. If we shall only do one development project, then maybe this is the fastest. But it will never be that we can only have one welding machine. So there is a better way, and we call that a modular way, meaning that we can structure decompose this in such a way that we, for instance, take one power element when we shall have the small welding machine. I can take 2 or 4 when I shall have the big one. So here we will over time have the faster development, we will have the more predictable, we will have the better quality, we will be able to reduce our cost over time. So it is this basically how do we get from the left part here to the right part. And when we have this, let's say, complex product, then it's also mirrored in manufacturing. So when the product is complex, then the manufacturing will also be complex. So we have a little bit the two suicide approaches here, so to say, both bad design and bad manufacturing. And I can say a little bit about some of the areas that we work in. We are working with this in service, and we are working with DSV. That's now the biggest third-party logistics provider in the world. And the funny thing is that service has the same nature as the physical product. When you are in 180 countries, you have invented 180 ways of doing logistics. And 180 ways they cannot all be the best way of designing, you can say. Then we are into this plant architecture, so big complex system, and I'll say a little bit about that later on. Then here in our area, pharma manufacturing is a big thing, and these pharma companies, when you can sell everything you can manufacture, suddenly the development of the manufacturing becomes very critical, and therefore we have a relative big initiative on that. And then we have something on architecture scaling. And many of these modular architectures, they were designed years ago. And if we take Lego, it was the mold architecture was designed 10 years ago when Lego was half size of what it is today. So it means all the molds are too small, all the plastic injection machines are too small and such thing. We're also in maintenance with total energies, and we are in construction in the building, and we are in the modular patrol ship. And with the crazy guys that we have in Moscow and in other places, we will for sure here in Europe start to take some bigger investment in it. And today we have that every country is designing their patrol ship, and it means that the ability to work together, the ability to share the weapon system, the ability to share the radars are very poor. So we have an idea here that we should have, let's say, a European standard, or maybe ideally seen a NATO standard for how we can do this. It means we could have more cost-effective patrol system. It means we could consolidate the purchasing instead of having locally in each country. And then we're doing something on configuration. And again, to illustrate a little bit the problem here, you shall imagine this is a product, and this is some medical thing that can take one sample. And now we shall develop a a product that can take 20 samples. And then the idea is that we introduce such a loading unit. And then what is happening is that in all the red areas, we will have to do a little bit update. Now the valve has to be a little bit bigger. Then the control has to be changed a little bit. Then the software has to be changed and such thing. And this is why R&D projects are always late, because no one can make a plan when there are so many dependencies here. This depends on this one. And that's why in Denmark we have the joke that R&D become an abbreviation for relax and delay department. And that's of course very unfair, because they do the best they can. But when we design in this way, there's no way we can make a kind of predictable plan, you can say. And then this time to market and time to money, it means we can maybe launch a product, but it's not really a mature product. It will sit with a lot of quality issues and such thing. And then this has all these, let's say, bad things. So what shall we then do? And if you can only remember one slide, this could be the slide. This is trying to illustrate. Here it's a very simple example. It's a company manufacturing hydraulic cylinders, and we sell them for the wind industry, we sell them for offshore, and we sell them for German automotive. And you can say here we design unique cylinders, we try to do something in wind, and you can say here speed is important, because we will not delay a wind turbine project because you cannot do the hydraulic cylinder. In the offshore, it's the backward compatibility that's important. And in German automotive, it's the cost effectiveness. And then we are busy designing them, and then we have the manufacturing process here. We get more and more parts in stock. We have bigger and bigger test issues and such thing. So the funny thing here is that we become slower and slower. We become more and more less cost effective here over time. We can never put any automation on this because everything is different. So what shall we do? What we have been trying to develop is a systematic method that we can stabilize the interfaces in such a way that when I shall have a new connection, we can change the connection without impacting the rest. And it means that we can react faster here to the wind segment, and we can afford automation. It will be cheaper to put the robots on the line when we are having them here, so to say. So the power of, let's say, modular thing is that we both sit on the market agenda. We can become faster, we can become more effective, we can be better on the engineering design, and we can also become more effective in manufacturing. And that's why we think it's so powerful, but it's also telling the story that here we have a vice president of market, here we have a vice president of R&D, and here we have a vice president on manufacturing. And they would normally have three different agendas, sell something or sell anything here, and develop and manufacture. So it requires, let's say, a coordinated approach behind the three areas. But if this can be done, we can do something that's we think is more powerful than almost any other things that you can do in modern companies. And again, here you maybe have 80,000 parts, and down here you have maybe 30 module areas. And here we are very busy on optimizing the 80,000 part. You have a very, very complex way of running an organization. If we are down here, we have 30 module areas. The 30 module areas we can take care of. So the 80,000 part you cannot manage, but the 30 module areas you can take care of. And if we have time for one more slide, then you can say another way of visualizing it is It's about the needs. We shall do different trucks. And then it is about interfaces stable over time. And then it is about performance steps. And now you can see, now we can make a new truck. Now we can make a new truck. It's also what we call the Las Vegas machine. And we can make another one here. And again here, if I now have a new idea for a gearbox, if we don't share the interfaces and I have 100 trucks, then it means I'll have to do 100 small development projects before I have deployed the new gearbox. So here you can say, here sits the time to market. We can be faster than any other. And here sits the cost effectiveness. We can have fewer engines. We can have something that can really be scaled. And this has been proven for many years. And this is an example from Scania. And Scania is the most profitable truck company truck development company in the world. And they have roughly half the parts of Volvo, MAN, and Freightliner, but we are 2 times more profitable than the alternative. So that was a little bit the short introduction. I think I have used my 15 minutes. I'll be happy to continue, but this is just very roughly the basic idea. And then you can say we have developed a set of tools, method that can guide you on how do we get to here.
Thank you very much, Niels. Perfect on time. Thank you.
Thank you.
So let's now move on. As mentioned before, Sergio Lasca could not attend, but today we have Giovanni De Santis, sales manager of R Quadro, and the key account that follow Pirelli, that will go in depth to describe which were the activities and the business benefits that R Quadro provided to Pirelli. So Giovanni, the floor is yours.
Thank you. Thank you so much, Silvia. Let me share my screen. And please, could you confirm that you can see
Yeah.
the full screen mode?
No, not full screen. Yeah, now yes.
Not full screen.
Now yes. Yeah. It's a bit of delay.
Okay.
Yeah, thank you.
Yeah. Thank you to Silvia. Thank you. Welcome to everybody. As Silvia said, I'm the key account on the Pirelli client. I'm talking not on behalf of Sergio Lasca, but I will present the innovation reveal solution for Pirelli. Pirelli, no introduction is needed about Pirelli. I suppose it's a worldwide leader in production of tires for all kind of vehicle, for cars, for heavy duty motor bicycle, and so on. And this top premium level of tires, and one of the most important company in Italy, also with reference to the patent activity. It's every year is the first or second position of the chart of most relevant filing application in Italy. No introduction is needed about Pirelli. Maybe something more we can say about the tire. The tire, maybe we can think that the tire is simply a tube of rubber filled with air, with grooves on the other side, and assembled to a wheel of a car. It's not true. The tire is a very, very complex system, both with reference to the parts, the components, and to the processes, to the methods. there is a strong mechanical engineering work around a tire, about assembly processes, about parts, about solutions. There is a very strong chemical engineering aspect about compounds in order to ensure the needed performances and so on. And in recent years, tires are often provided with the sensor, with the electronics components and so on. So the system tire, it's a very, very complex system, and there is a huge inventive activity in this world. And which is the problem? The problem is that every year, due what I just said, thousands of new patents are published, are filed, and are published. Think that Innovation Reveal for Pirelli, in Innovation Reveal are collected almost 1 million of documents that are patents related to tires, patents about tires, about sensors that can be used in a tire, compounds that can be used for tire production and so on. About 1 million of patents, a little bit more than 400,000 patent families. So this is the volume. Okay, these are the numbers. It's quite impossible to retrieve information with a proper level of accuracy manually, let me say, or using traditional instruments. So the problem is manage this quantity and this volume of information to understand emerging innovation, to understand what competitors are doing, and overall why they're doing something. So the solution of competitors, the problems that those solutions can solve, and even verify if a solution developed by Pirelli could be in infringement with other patents. So, and it's quite difficult to understand all these things searching into 1 million of documents. So the idea is to design, to build an organized archive, a sort of shelf, okay, a repository of information structured in a way that can make able every people in Pirelli to retrieve the information easily, okay, and with the needed level of accuracy. And in order to obtain this result, this organized archive is composed by several main categories that have been designed according to technical specification of Pirelli and that are compliant to the internal organization of the company. So people that is working on, let me say, components can find the drawer. Okay, imagine a library, a shelf. You can open a drawer about components, and he can find all and only patents related to that category. This is a very important point. So the added value of Innovation Reveal for Pirelli, for the rest of our clients, is that the initial domain and both the initial domain and each category are designed and created and implemented according to the technical specification of the client, are customized on the client needs. And just selecting one or more category and So opening one or more drawer, let me say, and sorting by relevance the documents contained into each of this category, all and only the documents related to the category can be easily found by two or three very quick and simple operation. The best quality of the result of a search with the lowest effort, let me say. The accuracy is ensured by the highest level of recall. So the category is complete. All documents related to that specific topic are contained in that category. So reducing or avoiding the risk of missing relevant information when I select a category. And the precision of that category is the level of the precision is the highest level possible, because the noise is reduced. Patent not on topic with reference to that category are not included in the category. So selecting the category, I have all and only documents I need. I can so perform an ongoing monitoring of the activity of the technological field and of the competitor, and I can easily search for specific solution, just selecting and sorting in a very easy way. And Innovation Reveal is also provided with tools that make easier the analysis and the reading of the documents. The Tag My Peak is our tool that can associate the image, the figure of a patent to the text. So I can start analyzing the picture and very quickly find the reference into the text, or vice versa. I can read the text and in a few seconds I can find where that feature that I found in the text is contained in which figure. There is the problem solution extractor that can provide the technical problem and the related solution of the patent. That is the core of the invention, the core of the content of the patent, the core information of the patent. So I can select and I can retrieve the relevant information in a very easy way. I can read the document. I can share the information because I can comment the document. I can evaluate the document, and that comment, that evaluation can be shared with my colleagues, other colleagues of mine, other colleagues of my team, or other teams in the company. And all this means that not IP specialists, so R&D people, for example, that are not from the IP department, but the R&D department, are enabled to retrieve relevant information to the patent and to collaborate and share information with the IP department in real time, let me say. They don't need to be expert and skilled on the patent itself, so IP specialists, but they just need to know what they are looking for, what they are searching for, selecting the category, sorting, insert, evaluating, analyzing the document. So the communication between R&D and IP, it's mandatory in order to increase the awareness within corporate function, within all the companies. This was one of the main goal of this project with Pirelli. The detection of new technological trends and the monitoring of the competitor activities, it's very efficient but effective, both efficient and effective. And in a very easy way, there is also, for example, a module of analytics that can show So aggregate data can be shown in order to very fast understanding of what is happening into the technological field. And of course, the IP people are able to perform very effective prior art searches in order to reduce the risk of infringement, in order to address the R&D activity, highlighting obstacles or empty spaces, being sure of the accuracy of the results. This is an important point. The threshold between the how is simple to retrieve the information and the level of the quality of the results. That is the maximum level possible, because the final user, both IP and R&D people, is not relevant in the sense has the total control. The final user perfectly knows what is containing into a category, what happens if he or she selects a specific category or sort according to a specific characteristics. So the control of data, the level of quality, and the possibility to have to organize the information according to the needs of the company. These aspects made the innovation reveal for Pirelli a success use case, and allowed Pirelli to increase the technical knowledge in a field that, as we saw, it's a very complex field and full of invention, and with a very huge inventive activity by other very big players. Thank you. I suppose that
Thank you.
stayed with the times. Welcome.
Perfect on time. Thank you very much to stress the business benefits that Innovation Reveal provided to Pirelli during our collaboration. Let's now focus on another aspect. It's a great pleasure for me to introduce the third speaker of today, that is Paolo Leonetti from Stetel. Paolo Leonetti is partner and business developer of Stetel with over 40 years of experience in the ICT industry, that will now present the significance of IP intelligence in enhancing the development of electronic devices and companion software applications.
Okay,
Paolo,
thank you very much. Thank you very much. Good evening to everybody. Let me share my presentation.
Yeah.
Yeah, I'm trying to extend it. Okay.
Yeah, perfect.
Can you see it? Perfect. Thank you very much. My name is Paolo Leonetti. I work for a small company. I don't work for a large organization. The company I work for is Stetel. I worked for a large organization in the past. And I've been working in the IT industry since I started in 1985. Yeah, so very long time ago, so 40 years ago. Stetel is a company. It's a small company. It's 30 people. We are based in Livorno, that is near Pisa. But because we have only customer abroad, so 100% of our turnover comes from outside Italy, and mainly from Germany and the UK. I actually live in Germany because I needed to look back to our customer and to the business from, let me say, from the country itself, from the place. As I said, the company is small. We have our core business is actually software development, and we do software development in the telco environment. But a few years ago, because we have seen that the business in the telco is not going up, is not increasing, is actually shrinking, we decided to de-risk our the part of the revenue of the company, And we decided to invest in a new branch, and the new branch, because of the background of working in the telco industry, we decided to go through is the IoT. So we did quite some things during the past year in IoT. Is where we actually got in touch with the patent word or a domain. And what I want to tell you is really the experience we have done during the past few years, and where we found the analysis of patent and other technical documentation that is available from the market really helps in driving the development of your product. This is really my experience of the company. It's not a theory, it's not rocket science. Unfortunately, to be able to set some background before I go really to the specific, I need to tell you something about what we really do, because this really is the core of our activities, and where we have found the requirement, the necessity from a business point of view to register some of our devices, patenting them. So the path of the journey the company have been following in setting up this IoT department is that we started with geolocation at the very beginning with trackers that were not using Wi-Fi, were not using GPS, and using Wi-Fi and the mobile cell. Then we added the ultra-wideband because we saw geolocation is something that is really interesting in the market. And we have implemented a system to do indoor geolocation using ultra-wideband and using trilateration and angle of arrival. This was the first step. The second step was to add artificial intelligence to the system. And we have developed both devices that are actually powered by artificial intelligence. We do mainly analysis of waves and sounds and vibration. And also we are using the AI to improve the quality of the indoor geolocalization. So to actually have a better result in the field. The accuracy is much better when you use when you actually can correct the position of a device inside a controlled area when you use AI, and that makes it very easy. The last thing we added was blockchain. We added blockchain because we want to find out what are the ways we can monetize or can help people or customer and user of our devices and our system, how we can use them to monetize different business model than we have today. And this is something we will touch very lightly. So at the end, we created an all-in-one automotive use case that goes from the geolocation down to the blockchain, and I will show you a little bit. And then we go to the details of the patent. What is geolocation? I think you all know. You have ultra-wideband anchors. You have ultra-wideband tags, and the tags are connected to the anchor. And depending on the system you are using to measure or to calculate where the position is, you can actually define how your things are moving. And one of the application use cases, of course, to put the ultra-wideband tags on a pallet that are in a warehouse where you are actually using the material in the pallet to supply the factories with the supply chain of the factories. We added a piece of machine learning, as I told you, because we needed to have a much better accuracy that one you can derive from the ultra-wideband activity and calculation. And we're using it, we do machine learning before we actually put this system live. So when before going live with geolocation, we go around in the factory or in the warehouse with a tag, and we measure what position we have, and the position is not correct. We are doing machine learning. We ingest this data into the training set of the artificial intelligence in order to create a system that gives you better accuracy. We created the two devices. One is for trilateration. So this is using the time of flight to calculate the position. And the second one is using the angle of arrival. So the angle, the waves are arriving, are hitting the device. The first one is the one that is more interesting from a patent point of view, because we patented it, and this is the one we are going to discuss later on, and to see how the patent analysis helps us in driving really the development of the device and of the product itself. This is actually the full picture of our system that we use for geolocation. We have the ultra-wideband tags, we have the ultra-wideband anchors, but we created a system that is able of changing the technologies using to geolocate in order to cover areas that are not under the control of ultra-wideband, meaning that if you move a good outside the warehouse where you have the ultra-wideband anchors, you can still try to understand, or you can have an understanding where the good is, even if the currency is lower than using ultra-wideband. We will see it later on. The last thing we introduced is the let me say, blockchain for IoT. We developed a device that includes a lot of, this is a development board, we call it, because it includes a lot of sensor. It has a possibility to communicate to 5G, through narrowband IoT, that is actually 4G, and also through Wi-Fi and the Bluetooth. Inside of this board, we included what we call a secure element. That is a chip that is capable of executing secure operation inside the chip. And the most important operation are the generation of the key for encryption and signing of the data. And the second one is to generate also an ID for the device, for the chip itself. And this ID, we use it to create a non-fungible token so that the device can be defined into the blockchain. The architecture I worked is like this. We have the device with a 5G communication, a microcontroller, and the secure element, and all the sensor. We communicate through narrowband IoT or through Wi-Fi to a middleware we have implemented that offer APIs. We orchestrate the traffic of data. We save the data into repository, and we connect it to the blockchain. What do we do with the blockchain? First of all, we assign the ownership of the device to a crypto wallet. So the person that owns the device, or the company that owns the device, have all those devices in its crypto wallet. The other thing we do is that we can offer the possibility to register data that can be accessed by external world through a fee. So data are available in a repository, but you can actually, through financial transaction in the blockchain, buy the possibility to access to the data for a number of time or for a specific period of time. This allows us to offer this solution to businesses like the private business, and we've been looking to the automotive, where you wanted to monetize from the data that your car is producing, because the car you own has a lot of sensors that belong to you at the end of the day. And the second one is that you can use the car, you can rent the car, and you can dematerialize the key of the car, so that you can actually give to somebody, you can grant somebody to use your car for a specific time of the day, and you can charge your customer to use your car. That's the same if you replace the car with a house, it would work exactly the same. You can use it also privately. You can actually give a key of the car to your son and say, dear son, you can only drive from this time of the day to that time of the day, and you do all this through the blockchain. I skip a little bit the use case with this is really the application to the automotive world or industry. And as I told you, the idea is to give to the owner of the car the possibility to monetize on the data and on the use of the car that is definitely your asset. But how does all this have to do with patents and intelligence on data? Two of the boards that I presented you earlier, the ultra-wideband and the blockchain board, for both of them we tried, or we have worked through the exercise of creating a patent, or obtaining a patent for each one of them. On the first one, we succeed. we succeeded and we have a patent. On the second one, we failed. I will tell you why we failed just in a minute. But because we failed, we didn't really decide to continue and to find out a different way. We published the details, the technical details of the board on GitHub. So it is now open hardware, and whoever wants to go and to have a look to it can do it. And if somebody wants to use it, it can download the specification and some software and use the board. All this, the process that we're doing, we are using a methodology that is not our methodology. This is the Requadro methodology. We go first through the infringement clearance search. We call it also anteriority. We go through a gate one. We do the design around it. This is the phase that are more fascinating for me, because if without the design around, you cannot find the electronic is a word that is very crowded. There are a lot of patterns, and it is very difficult to find out what is the space you can go through, and you can actually say, this is my differentiator, and I want to patent based on the differentiator. We succeeded to do it with the ultra-wideband board. So of course you go in the more bureaucratical part. So you prepare the patent, the submission. We go to the WIPO. And then eventually you can go to international patents. The model we are using with Requadro is the engagement model we have is that we use Requadro as a service. We are 30 people. We do not have time or energies to really create some more advanced skills in our organization that can look to this world of patenting in full time. So we are using we have outsourced in principle these activities, and the company is doing well. So we have the resources. We can actually do that. Yeah, somebody may find himself in a different situation, but we didn't have really that much of a problem. This is the way we are actually using to work. Now, going back to ultra-wideband, why we have been able to succeed? We succeeded because we were at our scope and objective at the very beginning was really to develop or to submit a patent that was about the board 100%, thinking this board does this. So we went through the infringement clearance or to the anteriority exercise, and we found out that everybody is already doing that. But we thought that inside our board there is something very important. And working together with Requadro, we found out that the most important thing is this ability to change the scope of the board via software, so programmatically, so that we can extend the range of utilization, moving from ultra-wideband to Wi-Fi and to other different ways. And that was done, or this exercise with the design around, we're being able to review the patent submission. And if you look to our patent, the first claim today is really this ability to change and to modify the behavior of the board depending on where it is. So the system overall, it looks like this. And we have, as I showed you before, we have ultra-wideband anchors that are normally installed in the warehouse, and we have the tags that fly around, and we know where the tags are. The first step in extending the coverage of the system, that is one, it is in the claim of the patent, was really for a tag that is sitting on a box at the very border of the covered area. We have decided to transform it on the fly from being a tag to being an anchor. So being an anchor, it will help the other anchors to find where the other devices with the other tags are, but also will extend outside the coverage of the main system the possibility to find the tags. This is what we have in the patent. But because this was a very promising direction, we decided to go further. So we made the possibility, we implemented the possibility not only to switch between anchor and tag, but also to switch between technologies. So we implemented the possibility to switch from ultra-wideband to Wi-Fi. when you are on Wi-Fi, you don't have the anchors anymore. You have the routers or the access points that are installed in your premises. So that means that when you move further your tag or your goods, and you enter into an area that is only managed by Wi-Fi, you can still see where your goods are. And moving even forward, we decided, we thought, and what happens when the pallet goes in a truck? So when it goes in a truck, you're not Wi-Fi coverage, you do not have ultra-wideband coverage. So the idea was to create a companion app that may be installed in the device of the truck driver. And this app is able to see what it is in the load, what is loaded in the truck, and still giving the possibility to track the system. All these parts, we have decided to do, and we have been through because we had this patent analysis, and we saw that there were space in the industry to implement a device and a product like this one. I skipped this one because I see the time is going. I mean, it is not only patent. Patent is only one stream. Depending on where you are in this product development, you have different sources of information that you use at different stages during your product life cycle. These are the ones we are using. And actually, I indicated here also what is this life cycle stage where we use the different sources of information. The main one for us as a competition, of course, and you go to the internet, you search and find what you have to find and what other people are doing. But we are working with universities and research and development. And this gives you the possibility to see what the future technical landscape is going to be, where for sure the patents and the IPs, we have been discussing this quite extensively now. I have my big friend that is FCC from the United States, because we do electronics. It's very easy to find inside the FCC database the product that have been developed by your competitors, and because the FCC is an open database, and there are pictures also of the internals of the device, it's very easy to find out information you may need. And the other one is GitHub, is the communities. Everything that is open software, open hardware goes on GitHub now. And we have also published there our board, the specification of our board. Fun enough, when you end up with a cycle, you produce also information, and this information you produce goes back into those databases. And at the end, you will find yourself, when you search for something, you will also find yourself there. To really wrap up and to close everything, what are my nightmares? This is actually a bit of a self-assessment I made while I was writing this slide. But my nightmare is sometimes I have the impression that everything has been already invented, and I'm working against a very fast-moving target. So having the knowledge of what is happening in the market and what are the new technologies and how to keep the pace of your competition is definitely something important. And I have a lot of opportunities and I have a limited success. Meaning that if you look to the outside world, I could do 100 things. If I had 60 people other than 30, I probably would have solved 60 people today, but it's very difficult to catch all the business. What are the fixes? What the problem I've had during my experience is that I didn't start with the patent analysis early enough. So everything I had to do was actually try to reinvent and go back and recycle. Next time I will start much earlier to discuss the things with Requadro for sure, and to do analysis much earlier in the development, so you don't lose time. We need to keep up with technology, but putting together all those different sources and try to be able to understand and to see what it is happening outside is not only a matter of looking to them and using them, it's a matter of how can effectively use them. So the technology we use to search and to organize the information is very important. And of course, the design around is vital. Without design around, we do not find the green field that are still available, and we will probably miss the opportunity to develop our products. And the last thing is to be selective, at least for me. Hamsterkampf is a German word that is the animal that eats too much, and at the moment in time has a mouth full, and it cannot digest, it cannot eat anything. So I needed to be more selective, not to see everything I have around as something that I really have to address in my business. Okay, it was a little bit of a roller coaster.
Thank you very much, Paolo. We have only 2 minutes left, so thank you very much for your precious contribution. I kindly ask to launch the pool, the final pool, the ending pool, to the direction, please. Just to understand if you have appreciated the topics and if you would like to explore the topic further and be contacted again from us. In the meanwhile, maybe we have just time for one single question. Okay, I think that is for Giovanni. Why Pirelli choose you instead of other providers such as Clarivate and Aqua? If you can answer in
is it
90
for me?
seconds.
For Pirelli, yes,
Yeah.
90 seconds. Okay. But thanks what I already saw. So two main aspects. First of all, the possibility to customize, let me say, the platform, in the sense that the possibility to design both the initial set and each category according to the needs of the client, to the technical specification of the client. In this way, the final user has the control of the content of the categories and the possibility to have the highest level of accuracy, of recall, and of precision. Other, let me say, competitors or providers provide a sort of raw data, that has to be post-processed by the user in order to extract the relevant information. In this case, the core of our platform is the post-processing of the data, and this post-processing is made according to the requirements of the client, ensuring the accuracy and then the best quality of the final results. This is I think the main difference.
Okay.
90 seconds. Okay.
Yeah.
Done.
Thank you. Yeah.
Thank you.
I see we are all here still. So maybe we can make another question that come. It's a bit longer. So modular architecture allows to scale, Prof. Mortensen. Innovation to improve performance, effectiveness, and efficiency. IP to protect, but in reverse, IP analysis can drive the R&D attention towards what to innovate. At component level, at subsystem level, at system architectural level. So if I got it right, architecture can guide the analysis or can be redesigned and innovate. So question number 1, how difficult is to find architectural innovation and patents? For sure, more than patents on component. Maybe this is a question both for Giovanni and Niels.
Okay, about can I start first?
Yeah, if you want.
About okay. No, because the question is always difficult to find in patents. It's very difficult. Actually, it's it's the challenge starting from Requadro was born, and the solution of Requadro, the algorithm of Requadro, is an algorithm allowing to search for not the keyword, okay, not using only the keyword like as in a Boolean query, but going up at function level. So if I write knife in a Boolean search engine, I will find documents containing the term knife. If I write knife, let me say, in the Requadro tool, I will find all things able to cut something, to perform that function. In this way, I can find different structures and alternative solution. So if I am searching for something to cut, okay, a material, I will find knives, I will find saws, I will find lasers, laser heads to cut something. And I can replace, okay, the solution I am thinking about or I'm using, for example, the saw, with a solution using another physical principle, but performing the same function. This we made a lot of time for our clients, and it's a difficult, it's challenge, and the challenge we let me say we face it, and we want with our algorithms in this way. Stop.
Okay.
I'm afraid about the time is going.
I don't know if Nils want to add something.
No, maybe a small comment. I do not have much experience in pattern search, but it's always coming up when we have the modular architecture. Can we then protect the IP to the same level as it was integrated? And I always have the same answer. If we have 20 drivetrains in Electrolux, then where will you bring the most innovativeness? Where will you bring the best IP? Will you have 5 that you can actually manage, or 20 that's average, so to say? So I don't think there's any bad correlation between IP and modularity. Quite on the opposite. You have more time, you can put more horsepower into developing them, and it sits, let's say the secret IP sits inside the modules. So I don't see any trade-off, if that is the question here. Quite on the opposite. I think they go hand in hand. The more horsepower you can put in, the more IP you can develop.
Thank you. Thank you very much to all the speakers for their contribution and for the audience to be here today. Stay tuned for the next appointment of Requadro. The next one will be in June, and the topic will be MedTech. So see you soon, and have a nice evening.
Thank you.
Thank you. Bye.
Bye-bye.
Bye-bye.